In this lesson, we're going to divide rational expressions, and it's going to be real similar to multiplication, but I do have to add one step. Recall that if I am dividing a fraction, say 3/4 divided by 2/3, what we do is we can change that into a multiplication problem by saying 3/4 times, and then we take the reciprocal of the second fraction, so it'd be 3/4 times 3/2. And we're going to use the same procedure when we're dealing with rational expressions. So we're going to have to convert our division into multiplication. Then we're going to just do what we've done before. We're going to simplify like multiplication, and we're going to have to specify the values of the variable that are going to make the denominator go to 0. So let's work some examples. So my first step in this problem is going to be to change that to a multiplication problem, and I'm going to do that at the same time I'm going to factor it. So basically, this factor here is going to be a numerator, and the factors of this part here will be a denominator. So I just don't want to take the time to rewrite that, so I'm going to do it all in one step. So I'm going to have 7x all over, and I'm going to factor the bottom part, so that's going to be 2 times x minus 5. And that's going to multiply now by the x squared minus 11x plus 30 is going to be up in the numerator position because I'm changing it to division, the division to multiplication, but I'm going to go ahead and factor it at the same time. So what that x squared plus 11x minus 11x plus 30 will be is two numbers that multiply to a negative 11, and add to negative 11, multiply to 30, that will be a negative 6 and negative 5. So I will have x minus 6 and x minus 5. And then for x squared minus 6x, let's pull an x out of there, and I will have x minus 6. Okay, so now then I have set up my multiplication problem. I'm going to go ahead and specify where the denominator will go to 0. And so I can see that x equal to 5. Can't have that. I can't have x equal to 6. And I cannot have an x equal to 0. Okay, so let's go ahead and multiply these together, and to save some time on the video, I'm not going to rewrite it. We realize that when we multiply them together, these will all just be numerator times numerator, denominator times denominator, so it'll be one big fraction like that. And what would go away would be this x minus 5 and that x minus 5, this x minus 6 and this x minus 6, this x and this x, and I think all I have left is 7/2. Let's move to the next problem. Okay, so this one will have a 1 in the denominator, and when I factor it, I'm looking for two numbers that multiply. Actually, this is an AC middle, so I'm going to stop the video just for a second and go ahead and factor this term. This is going to take just a second, and since we are very experienced at this, I don't think I need to show you that. Okay, so I factored the 6x squared plus x minus 15, and that is factored into 3x plus 5 times 2x minus 3. So I'm going to go ahead and put that 3x plus 5, 2x minus 3, all over 4x squared, and that's going to multiply by the reciprocal of the second fraction. So that's going to be 1 all over. And I have 3x plus 5x. Those would actually add together and give me 8x. So what you can see is that my values of x that I can't have in the denominator, this one would be 0. That would cause a 0 in the denominator, and so would this one. So the only value that I can't have would be x can't be equal to 0. And let's go ahead and simplify this some more. So what I would have here is I'm going to have 3x plus 5, 2x minus 3, all over 4 times 8 is 32, x cubed. And at the moment, I can't see anything that's going to come out of that, so that would be a simplified form. Maybe I didn't write it down right from the problem. Next problem. Okay, next problem, let's go ahead and factor this. So what we're going to have is, we would, for the first fraction, we would have 4x, factor of 5 out, we would have x minus 4, and then that would multiply by the reciprocal of the second fraction. So I'm going to go ahead and factor the second fraction and move the denominator up to the top when it's multiplied. So the denominator would factor into two numbers that add to -6 and multiply to 8. So that would be equal to x minus 4 and x plus 2. Then my numerator, I can factor an x out, so that would be x times x minus 2. And of course, when those combine, once again to save time, those will combine into one big fraction. And we can see now what values of x would make the denominator go to 0. So for x minus 4, I'm going to have x equal to 4. Can't have that. I can't have x equal to 2. And I can't have the x equal to 0. Okay, so let's go ahead and factor out any common factors in the numerator and denominator. Those x's would go. I have an x minus 4, and I have a x plus 2 and x minus 2, and they're not going to be able to be simplified. So my final answer would be 4 times x plus 2 all over 5 times x minus 2, and that would be the way I would leave it. Okay, the last example of dividing rational expressions, and I went ahead and factored the 2x squared plus 3x minus 5 using AC middle. So we will write that as 2x plus 5 times x minus 1 all over 6x times, now the reciprocal of the second fraction, which would be times 1 all over, and 2x plus 5x are going to form to be 7x. So looking at the values that I could not have for x, I can't have either of those x's be 0, so x can't equal to 0. And combining those, I don't have, if I combine those under one big fraction line, what that would end up being would be 2x plus 5 all over x minus 1. 6 times 7 is 42, x squared. So once again, I don't know if I somehow wrote the problem down wrong. I don't think so, but there wasn't anything that canceled out there. So that's dividing.